Today we're going to start our next section, which is 5.5, and we're going to talk about many different types of identities in this section. The first one that we're going to deal with today is called the double angle identity. So this whole section is about multiple angle identities and changing things from a product to sum and a sum to product. These are definitely formulas that you're going to use again next year in calculus. So these are the ones that we are going to focus on just for today, the double angle formulas, and they actually come from the angle sum and difference identities. I'll show you an example right here with the sign. So if you have the sine of 2x, that's the same thing as saying the sine of x plus x, which is our angle sum and difference identity that we learned in the previous section. So if we expand this, we would get the sine of the first x, which would be this one, times the cosine of this x plus the cosine of the first x times the sine of the second x. Well, both products are the exact same. It doesn't matter the order. So if you combine them, you have two of them. So 2 sine of x cosine of x is where this identity comes from. The double angle for cosine can be found the same way, and if you do the same verification, you would get this first one here, which kind of reminds you of the Pythagorean identity. The other two versions come from the Pythagorean identity. What they did to get this one is in for sine squared, they put in 1 minus cosine squared. And to get this third one here, in for cosine squared, they put in 1 minus sine squared. You're going to use the best formula for whatever situation you're in at the time. And then the tangent is going to be found by taking the sine of u plus u, which is, again, our double angle identity for tangent expanded. So the first way that we're going to use them is for solving identities, or solving equations. If you look at this first equation, we have something funky going on. We have two angles here given for cosine, and the angles are very different. This would be like having an x and a y, two totally different things. We're doubling this angle. We have a single angle here. And we need to solve on the interval from 0 to 2 pi. One thing I want to mention, because I saw this on a lot of your tests, the last test, you're still giving me answers of 2 pi. At the beginning of the year, we learned this notation. When you see the bracket, that means you're including 0. When you see the parenthesis, that means you're stopping at 2 pi and not including it. We don't include 2 pi because when you already said 0, you already got the spot. So when you get back around to 2 pi, it's technically an open circle, and it would not be a solution that we would want for this problem. All right, so back to solving the problem. How do we take care of this situation where we have two totally different angles? Well, we got to use our identities that I just showed you. So we have an identity for the cosine of 2x, and we're going to use that identity right now and substitute in for it. Now, here's the deal. You had 3 to choose from. I'm going to use the one that would make the most sense for this problem. The other term has just a cosine in it. Therefore, I don't want to use the first one, cosine squared minus sine squared, because you would be putting a sine squared into the problem. I don't want to use the last one because it would be also putting a sine squared into the problem. So I'm going to use the second one that is all in terms of cosine. So 2 cosine squared of x minus 1 is what I am substituting in here. Then we have the rest of the problem plus the cosine of x, and that equals 0. If you take out the parentheses, because we have addition, subtraction, we really don't need the parentheses anymore. This is 2 cosine squared x plus cosine of x minus 1 equals 0. So this is a quadratic. We can factor this. We can do a and c plus b. If I multiply my first times my last, I get negative 2. The two numbers that I'm going to need for my middle number are going to be 2 and negative 1. And if I divide by 2, that tells me the numbers to put into my factored form. So my first factor will be the cosine of x plus 1, and the second one will be the 2 cosine of x minus 1, and this equals 0. So you're going to set your factors equal to 0. We get the cosine of x equals negative 1. We get the cosine of x equals 1/2. And now we need to look around the circle to see where cosine equals negative 1. Cosine equals negative 1 right over here at pi. So pi is one of our solutions. And we need to look around the circle and see where cosine equals 1/2. Cosine equals 1/2 in the first and in the fourth quadrants. So that would give you pi over 3 and 5 pi over 3 as the other two answers to this problem. Next, we're going to talk about how to solve equations in general when they don't tell you anything about the angle, and here we're just given a value like the sine of u is 3/5. You did this with the angle sum and difference identities. If you look at those formulas, we have the sine of 2u to solve for. We have the cosine of 2u and the tangent of 2u. The formula for the sine of 2u is 2 sine u times the cosine of u. Well, we already know the sine of u. They gave it to us. It was 3/5. But what we don't know is the cosine of u. So that's up to you to find by what they told us. They told us the sine of u is 3/5, and u happens to be between 0 and pi/2, which is a first quadrant triangle. So you're going to make a triangle in the first quadrant. Here's my angle u. Sine would be the opposite over the hypotenuse. This is a 3, 4, 5 right triangle. So now we can look at the cosine of u, and the cosine of u would be 4/5. And now you're just going to simplify your numbers. We're multiplying straight across with our fractions. And so on top, we're going to have 6 times 4, which is 24. And on the bottom, we have 5 times 5, which is 25. So there's your first answer. Second problem, we have the cosine of 2u, and you really have your choice of all three equations. I personally would use the third equation in this situation, because what if you messed up your triangle and you had to substitute in the cosine? Well, of course, you would get the first problem wrong, but then you would also get this problem wrong too, and you don't want to get all the problems wrong. So you're always better off just using the given information if you can. So I would use the third equation, which is 1 minus 2 sine squared of u. So we have 1 minus 2. In for sine of u, we're going to put in 3/5, and the sine of u is squared. So this is 1 minus 2 times 9/25. And we're going to multiply here. So this is 1 minus 18/25. And 25 minus 18/25 is going to give me 7/25. So that's the answer to the second problem. The third problem, you have some options. You can, of course, use the formula, which the tangent of 2u, that formula is 2 tangent of u over 1 minus tangent squared of u. It should remind you of the angle sum and difference identity. The tangent we know from our triangle is 3/4. So I'm going to substitute 3/4 in for tangent. On top, this is going to reduce to 3/2. On the bottom, I have 1 minus 9/16. So this is 3/2 divided by 7/16 once you get your common denominator. So this is 3/2 times 16/7. And so when you cross cancel and reduce, you get 24/7. And what you could have done, or you could use this as a double check, is we could have also done sine over cosine. So if you take this answer and divide it by this answer, you would see the 25s would cancel, and you would also get the tangent, which is what we have right here. Okay, next, they want us to simplify given our double angle identities. And when you look at this first one, you might be like, okay, what's that? That's not an identity, but it looks similar to an identity. It looks like the sine of 2u, which is 2 sine u cosine u. The only difference is it's not a 2 in front, it's a 6. So we could think of this as 3 times 2, there's your 6, sine of x cosine of x. And then this is our double angle for sine, so this is equal to the sine of 2x, and then we have the 3 guys sitting out in front. So this simplifies to the sine of 2x. That's not squared, that's a 2x. This one, if I look at this one, it reminds me of the pattern of 1 minus 2 sine squared of x, which is the cosine double angle identity. So the only thing that's different here is I have a 4 and an 8. Here I have a 1 and a 2. So if I take my 4 out of this one, I would have left 1 minus 2 sine squared of x, which is exactly what I have here. So now I can just substitute in right here the cosine of 2x, and this simplifies to 4 times the cosine of 2x. Sometimes you're not going to know the identity, and you know enough right now that they are going to make you start to derive your own identities for what you need. Next year, when you get to calculus, you're going to learn that you can't take the integral of any trig function unless there's a 1 in front of the x. So your job is to get this down so you have a 1 in front of all of the x's. And you look at this and you're like, okay, this is the cosine of 3x. I have nothing for that. But the cosine of 3x is the same thing as 2x plus 1x. And if you look at this, this is the angle sum and difference identity. So we can expand this using our angle sum and difference identity, which would be the cosine of 2x times the cosine of x minus the sine of 2x times the sine of x. Okay, so we still have some work to do. We got better here and here. Those have a 1 in front of the angle, but we still have a 2x here and a 2x here. So we use the angle sum and difference identities here. But in our next step, we got to look at these, and we're going to have to use the double angle. That green doesn't show up very well, so I'll switch to another color. So for the cosine of 2x, we have 3 options. Again, look at what else you have. We have a cosine over here next to it, so I'm going to choose the option that has cosine in it only, which would be 2 cosine squared of x minus 1 times the cosine of x. Then over here, we're moving on to the sine of 2x, and we only have one option for that one, so that would be 2 sine of x cosine of x times the sine of x. And let's put this all together. Let's do some distributing. Right now what we have is 2 cosine cubed x. That's in good shape because we still have a 1 in front of the x. Minus the cosine of x. That's in good shape. Minus 2 sine squared of x times the cosine of x. And right now you might be like, oh, you're in great shape. But the other thing is, too, is if you can, you want to try to get it all in terms of one trig function. We have the sine thrown in here, so we want to try to get rid of this guy. And I see sine squared, so that makes me think of my Pythagorean identity, which is 1 minus the cosine squared of x. So I'm going to substitute that in there and clean up this term. This over here is just fine. It's just going to wait. And what I'm doing here is I'm multiplying. So I'm going to kind of distribute from both sides. I'm distributing in the -2, and I'm going to distribute in the cosine. So now I have 2 cosine cubed x minus the cosine of x minus 2 cosine of x plus 2 cosine cubed x. And now I can put it all together. We have these cosine cubes, which would make up 4 cosine cubed x. And this is a cosine, and this is a cosine. I have a -1 and a -2, and that would make a -3 cosine of x. And now you have it all in terms of one trig function, and now you have a single angle in front of the x, which is really what we're after. Goodness, we have one more thing to do. Okay, we need to verify these identities. So you're going to build your wall. Cosecant, that's going to be 1 over the sine of x, or theta in this case, over the cosine, 2 cosine. This denominator is really like putting this denominator together or reciprocating and multiplying, whatever way you want to look at it. So this is 1 over 2 sine of theta, cosine of theta. And then this is an identity. This is our double angle. So this is 1 over the sine of 2 theta. And if you look, we don't want to write it as a fraction. We want to write it as the cosecant of 2 theta. This one over here, build my wall. I'm going to do some foiling here. So this is the sine squared of x plus 2 sine x cosine x plus cosine squared x. Hopefully you see it. Cosine squared plus sine squared is 1 plus 2 sine x cosine x. This is our identity we learned today. This is 1 plus the sine of 2x. And there's your verification. Okay. You have some homework. You need to do this. I'm going to post the answers today so you can check to see how you're doing. And on Monday, you're going to have a little quiz on all of this stuff. So be prepared for that on Monday.